So for our second introductory talk, which is entitled Redefining Intelligence, we are pleased to welcome Carl Wieman, who is the 2001 Nobel Laureate in Physics, and he has also spent a quarter of a century thinking about science education and how that should proceed in the future. So, Carl Wieman.
Okay, well, I'm just going to talk a little bit about rethinking what we really mean by intelligence, and I'm focusing on the human aspect. And my main point is to think of it as something that's really created rather than some inherent characteristic. And I'm going to start with a definition that I use, which is really the ability to do complex, worthwhile cognitive tasks, worthwhile as judged by what people see as important. So I have to say I don't rank Jeopardy as very high on the intelligence scale. But looking at the human brain, I mean, it's been biologically, it's been the same for, many thousands of years. And so that raises the question of, can its intelligence really be enhanced? And the argument I'm going to make very briefly and with not much nuance today is that, yes, it can be by enhancing the learning of it. And as we understand how the brain functions and learns, we can really enhance its learning and thereby its ultimate intelligence. So start with, there's a long history of people working on developing ways to measure sort of basic ability, and start thinking about it as a natural ability or intelligence, IQ at some reason, and then establish from that what the corresponding limits are on people's cognitive capacity. And the idea that you can do this, frankly, is mostly supported by a combination of myth and a mixing up of prediction with cause. So you give a bunch of kids IQ tests, and then the ones that score high, you give them special teachers. The ones low, you give them crummy teachers. And then lo and behold, later on, the ones who scored low on an IQ test do worse in school, so you decide you have predictive ability. That's not, of course, that's cause, not really prediction effect. And so the overall evidence that you can do this is really basically weak. And the reason it's hard to do these kind of predictions is two reasons, and I'm coming at those as really the basic justification for my whole rethinking about this problem. The first problem is that the results from your tests, they should correlate with recognized worthwhile accomplishments people can ultimately do, and you'd like them to correlate strongly. These days, people who work in this are happy to get kind of any modest predictive statistical capability. But secondly, if these IQ tests are going to be measuring something fundamental, they shouldn't be easy to improve on just by practice at the test. And both of these are quite hard to achieve, particularly the latter one. And so this is an example of what's sort of, I'd say, good or among the best results in this field of person looking at people's performance on this complex video game. This is a air traffic controller simulation, having people practice this over time and seeing how much this a collection of people, how much better they get here, and having given a whole bunch of tests of ability and IQ that seem related to this. And, this is the average, but within here, there's plus or minus 10% or so fluctuation, and these initial tests can predict about 25% of that variation. So in this field, so that sounds good, but then you think about, but the effect of practice here is far more than that amount of variation. And so the whole point I'm getting at is really practice always, as it does in this case, dominates over the predictive value of something like ability or IQ. And it gets even worse in terms of how poorly the predictions are compared to the impact of practice as the tasks get more complex and as the learning takes longer. And so the basic point I want to make is that really there may be other things that matter, but they're always small compared to ultimately the quantity and quality of the training or practice or learning, if you like, of what people are trying to do. And you see these same curves over and over for pretty much everything you can measure in terms of what you want people to do, including these complex, worthwhile tasks that I would start out with. And so based on this, as the coaching and training has improved, you find ways to improve the quality, you find ways to make this go up faster and to higher here. And we see this improvements over the decades in athletic performance, music virtuosity, even things that you might think are more fundamental, memory, as people have learned to train memory better over a factor. Just the last 20 years, the records for memory capacity have tripled. Now, those seem like sort of basic kind of mechanical things, but getting closer to my own work, we find that even things like mastering application of physics concepts, we can find better ways to train, i.e. teach students on that, and we can double. So instead of going up like this, they're going up here to twice the height by finding better ways to teach them. So this kind of enhanced learning, it really requires a deeper understanding of what's really involved in these cognitive tasks, how the brain thinks about them and how it learns them. And then you have to figure out how to put that into the instruction and practice for the learners. And so we're still fairly new, really, in this field and working across areas there. But I want to give you a few examples. Probably the best data really is from the kind of work I'm in, where we look at post-learning of science at the post-secondary level. I've already mentioned we made great strides in how people can better learn physics concepts and other areas in science. Looking at a more lower level, my colleague Dan Schwartz has looked at how the brain processes and thinks about numbers at a very basic sense, and realized that by teaching children in terms of teaching about negative numbers, teaching them to think about this as a model of symmetry, as a reflection of the positive number scale, he's actually been able to improve by, in their measures, about 50% in the capacity of children to understand and use negative numbers. In other areas, again, back to really my own work and people like are doing, looking at testing the validity of scientific models. We've been able to make dramatic improvements at how expert-like students can become at doing that in the same amount of learning time. And finally, touching a little on creativity, coming up with creative mechanisms, reasonable mechanisms, and creative ways to explain novel biological processes. We've found dramatic ways to improve the learning of that as well. And so just to finish, I'd like to argue that really I see the future of human intelligence is very directly related to the idea of this enhanced quality of learning of complex skills, that we can reach higher levels more rapidly and make this much more widespread about the population, ultimately really reaching higher levels of expertise than we have now. And then ultimately, this really does mean increased human intelligence. Thank you.